Hey guys, just want to take a few minutes here to kind of go over some of the concepts that we just tested on and clear up some misunderstandings for you guys, make sure we're all on the same page before we do a test retake. So I've jotted down a lot of things here on the board. These are things that I'm going to go over with you guys over the next few minutes. Okay. So remember we started this unit with the metric system. So our basic metric units that we really want to focus on are the grams, liters, and meters, right? So the grams are what we're going to measure mass in. And then the variations of those would be our SI, would be the metric system. So like kilogram is 1,000 grams. I'm not too worried about the metric conversions right now. It's just understanding that the grams would be a measurement of mass. Liters are a measurement of volume, so how much liquid is in a container. And then meters is a measurement of length. So I've got here a meter stick. This is 1 meter long, right? On the side here, I've got it broken down into centimeters. There's 100 centimeters in 1 meter, right? So depending what I'm measuring the length of will determine what variation of that meter I'm going to use. If I'm measuring, the length of a fingernail, I might want to use centimeters or maybe even millimeters. If I'm measuring the distance from Kansas City to St. Louis, I don't even want to measure in meters. I want to measure in kilometers, right? 1,000 meters at a time. And even then, it's still going to be like 150, 200 kilometers from St. Louis to Kansas City. So it's still a big unit, right? Okay, how do I measure those units, right? What do I use? So if I'm measuring mass, we use a balance, specifically a triple beam balance. Remember, mass is the measurement of how much matter is in an object, so we have to measure that against a known quantity. So a triple beam balance does that. It measures the balance between your object and a known mass that's sliding on the 3 different bars. Liquid or volume that we measure in liters would be measured with a graduated cylinder. So it's going to be a nice tall tube that has graduated marks so we can figure out how much is in there. And then for the length per meter, typically we use the meter stick. Again, if it's something smaller, we might use the centimeters. If it's bigger, we might use the kilometers. All right, scientific method. We talked, this whole unit is really about the scientific method. So this is kind of the big thing, and this is what we base our whole year on. Like, we're going to revisit this every unit. So we got to really make sure we understand that. The first thing to understand is that we don't always have to do these steps in that exact order. Sometimes we'll only do a few of the steps, all right? But generally, it follows this order, okay? So we start with an observation. An observation is using our senses, our sight. We see something happening or we hear something happening, right? And we ask why. Why did that happen, right? Sir Isaac Newton sitting under an apple tree, and an apple falls and hits him on the head. He wonders, why did that apple fall? Right? When it came off the tree, why did it fall down? All right? And that started his ideas of the laws of motion. Right? So an observation is using all of your senses. Sight, sound, or your hearing, your smell, your taste, even your touch. And then usually what happens is you ask a question. Why does something do that? Or I wonder, how does A affect B? Right? If I were to change A, right? If that apple was heavier, would that change how it falls? Right? So how does A affect B? And that A and B, we're going to learn later, are independent and dependent variables. Right? So it's very important that when we write a testable question, that we write it in this format of how does A affect B? Okay, after we've made a question, we want to write a hypothesis. The hypothesis is really a scientific or educated guess of what we think is going to happen. So remember, a hypothesis is going to be an if-then statement. So if I'm talking about how does A affect B, I might say, well, if I increase A, then B will also increase. Or if A increases, then B decreases. So I'm telling you what's going to happen to A, or how I'm going to change A, and what I think is going to happen to B. Remember, the hypothesis has to be testable, right? How we got to be able to check it out. And it ultimately, like I said, it's that educated guess or a prediction of what's going to happen. All right, so now that we've made our guess, it's actually time to do the experiment. So we want to try this out, all right? And if we're going to say how does A affect B, then we want to change A up some different ways, okay? So remember when we do an experiment, we should have steps written down. And we do this for a couple of reasons. One, we want to do this over and over and over again. So we want to make sure we do everything the exact same way each time. And we do that by having a set of steps or procedures, right? Again, we want to do multiple trials. So if I say, how does A affect B? How does mass affect the flight time of a paper airplane? I'm going to try to get 3 to 5 different masses. And then for each mass, I'm going to do multiple trials. That increases my reliability. Because if I have just one trial at each mass, how do I know that was a good trial? If I have 3 to 5 trials at each mass, and I see that one is really off, I can throw that out. If I have like 8 to 10 trials of each mass, right, I can really start to get some reliable data. Also remember we have a control group. So when we talk about changing A, in this case I'm changing the mass, the control group is going to be my unchanged group. So either I have not changed anything with it, or it's my very lowest value. So if I talk about mass, what's my lowest mass? That's going to be my control group. And the reason we want a control group is to measure a change in our results against our original process. We want to know that if I change that independent variable, that it's going to give me a change in the results. Okay, after we've collected some data, we want to analyze that data, and the best way to analyze data typically is to make a graph. We're going to talk a lot about graphing here in a little bit. All right, so that's the analyze step, and then the conclusion. Right, we want to make a summary or a claim of what happened. So we summarize. We're going to talk about we're going to repeat the testable question, repeat our hypothesis. Here's where we say, hey, my hypothesis was right or it was wrong. Doesn't mean we failed. Doesn't mean that we did something wrong if our hypothesis was wrong. Because remember, it was a prediction. It was a guess. So it's okay if we're wrong. We then take that information to make a claim, right? So if I want to say how does mass affect the flight time of a paper airplane, and my data shows that as the mass gets heavier, the flight time gets lower and lower and lower, right? Less and less time, then my claim would be that the more mass results in a shorter flight time, right? And I would support that with data. Okay, so in our experiment, we've got several different types of variables. So there's lots of things that can be changed. If I go back to my paper airplanes, remember we talked about all the different things that can be changed to make that flight last longer or for it to fly further. We can change the mass. We can change the shape of the plane. We can change the type of the paper, the design of the paper, right? How hard it's thrown. Those are all different things that can be changed. In order to have a reliable experiment, we can only change one of those, right? So the one thing we change becomes our IV, or our independent variable. And that IV is going to be whatever A is here. How does A affect B? How does the independent variable affect? And then B becomes our dependent variable. That's what we're testing for. So if I'm testing how does mass affect the flight time, the mass is my independent variable. That's what I can change. I've got control over it. And what I'm going to measure is the flight time. Everything else that could affect that flight of the plane, I want to keep the same. So I'm going to keep the same plane, and I'm just going to add mass to it. Because even if I made some different planes with different masses, but folded them exactly the way, I may not fold them exactly 100% the same. So by using the same plane and just adding like paper clips or adding staples, would add mass without changing that plane too much. And those are what our constants are. And the reason we have constants, again, is so that we know if there is a change in that dependent variable, that we got a measurable result, that it was as a result of our independent variable changing. Okay? All right, so that's that part so far. I'm going to shift over here so we can talk about data tables and graphing. All right, so the first one, data tables. Remember, in our simple data table, we're going to have, sometimes you might only have two columns, but your independent variable is always going to go on the left-hand side. That's the first thing. And you would usually go in increasing order of whatever's being changed. So if I did mass, I might have masses of, say, 2 grams, 5 grams, 7 grams, 10 grams. Right? I would have increasing values. And then I would have my multiple trials. In this case, I'm trying to do 3 trials with each mass. Again, it gives me a reliable data to use. Okay. Also, don't forget with your labels here, so when you put your independent variable in, if this is going to be mass, I would want to write mass there. And I'd actually go ahead and put the G in parentheses to know that that's what I measured my mass in, grams. Notice I put it in my boxes here. If you have it in the parentheses, you don't have to have it in those boxes. Okay? And then same thing for your dependent variable. If I'm measuring the flight time, then my flight time would be measured in seconds. Okay, one of the biggest things that I've seen a lot of people struggle with is the graphs. So remember, we use our acronym TASP to remember what are the 4 main things we need on our graph. So T is our title. And that's just going to be kind of our question, how does A affect B? Or we kind of turn that around a little bit, and it'd be the effect of A on B. Right? So we're still identifying our independent dependent variable within our title. All right, the A is for our axes. We've got to label our axes. So on the x-axis, this is always going to be our independent variable. Okay, in this case, this is what A is. And we're going to put the unit that it's measured in here in parentheses. And then on the y-axis will be our dependent variable, right, or B. And again, this is going to be what have in parentheses the unit or units that it's measured in, right? So if I'm measuring mass, I'm going to have it in grams, flight time in seconds. All right, the S is the scale. I don't want to have a graph that only uses like, if I'm going like to 10, I don't want to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and have my mass all be on this third of the graph. I want to space it all the way out across the graph. So if I had 20 slots, I might go 1 gram every 2 slots, right? Or if I had 30 slots, 1 gram every 3 slots. I would want to space it out to fill the whole part of the graph. Same thing with my time. If I notice my time only went up to like 3 seconds, I wouldn't want to number this up to 10, right? Maybe 5, but I would try to want to number it to just above my highest value. So that's going to be the scale. Make sure we have it numbered evenly. We're starting at 0, 0, and we're using the whole part of the graph that we can. The last part, P, is the plot. And the plot just means, so I'm taking my data point. If I've got 2 grams, and let's say maybe this was 5 seconds, and I go 1, 2, 3, 4. Maybe that's my longest flight. So at 2 grams and at 5 seconds, I have a dot. I don't have to label it. I don't have to write the coordinates. I'm just putting a point for each data thing I have. And what I might do, going back to this data table, since I have multiple trials, I might do another column to do the average. And I would graph the average time versus the mass. Okay, last thing I want to talk about with graphs is when do we use a bar graph versus a line graph? So a line graph is going to be when I have numerical data for both the independent and dependent variable. Okay, so I've got numerical data for the masses here. If instead I did it like with my paper airplanes, how many paper clips it had, it's kind of numerical, but it's not a measurement. It's just how many of the paper clips. I didn't really measure the mass. So then I might use a bar graph when it's a non-measured quantity, or I have 3 different designs, or I have a small, a medium, and a large plane, and I didn't measure the size. That would be the bar versus line. So line graphs when you have numerical data to use. I hope this helps you guys. And what you're going to get the opportunity now to do is to go back and retake that test, and we'll see if we can get a better score now that we've kind of gone through some of this information. If after going through this information you still have some questions, before you start the test, I want you to talk to me. Either if you're in class, come up and talk to me, or shoot me an email if you're at home so we can talk about that before you start on that test. Because again, once you start that test, you're only going to have 90 minutes. All right? So I hope this really helps. I look forward to hearing from you, and I hope to see those scores go up.